So hello everyone and very good afternoon. I hope audio video clear. I hope the audio and video is clear. So is audio video clear everyone? Very good afternoon. Vishnu, very good morning, very good morning. Just a moment guys, just give me 1 minute so that I have to upload the PPT on smartboard. Just give me 2 minutes. Your class will start in just 2 minutes. Understood? Just a moment. Just a moment guys, your class will start in just 1 minute. Just a moment. So today we will be covering the questions on slab and in evening we will be covering the questions on column. Okay. Is audio video clear now? Okay. Now it is clear. So we'll be starting with the questions on. This is the Telegram channel. In today's class, I'll be covering the question on good questions on slab, RCC slab. Okay. So today in today's class, I'll be covering the question on RCC slab. Is it clear, everyone? Clear? Okay. So this is the PPT. Okay, so few days are left for your RRB JE. Okay, these questions are helpful for your all the state AE and JE examination. I have framed the question in such a way that these questions are important for RCC questions are, and complete RCC will be covered from these questions, important for your state JE exam and AE examination. State AE and JE examination. Okay, you cover these questions roughly around. I'll take 300 questions. In evening also I'll take one of the session. Okay, in evening I'll be taking the session on column. Clear? Because yesterday I haven't taken the class, so in order to manage that class I'll take the class in the evening also. So in the evening I'll be taking the class on RCC column. Clear everyone? In evening I will be taking the class on RCC column. This is how we will proceed. Is audio video clear everyone? And this is the Telegram channel from the annotated PPT. This is the Telegram channel. Okay. You can scan this Telegram channel and you will reach to my Telegram channel. You will download the annotated PPT of this PDF of this file. Okay. So that you can revise anytime. Clear? Let's just start with the session. Start करें भाई. Please comment. Let us start the session. Okay. Okay. Let's just start with the session. So in today's class, the first question for RCC slab. Okay. RCC slab. Look. This is the first question. And this is a very good question. The overall depth for two-way support. Put a star mark on this. put a star mark on this. Solve the question. This is the first question. Solve the question, everyone. What is the correct answer? Now, the overall depth for a two-way simply supported slab is 300 mm. Okay, the depth is given in the question. So the depth is given in the question as 300 mm. So this depth is given. Understood, everyone? Find the span length. You are asked with the span length. So for two-way slab, the ratio for two-way slab, for the ratio of span by depth ratio is, answer everyone. I'm not getting answers. Okay, the depth is 300 mm for two-way slab. For two-way slab, okay, span by depth ratio, span upon depth ratio for simply supported and for continuous slab. Okay, for simply supported and for continuous slab, the value is given as, for simply supported slab it is 35 and for continuous slab it is 40. For simply supported slab, this value is 35. Okay, and for continuous slab this value is 40. This value is 40. Understood, everyone? In question it is given as two-way simply supported slab, and you can see that the depth is given as 300. So you are asked with the span. So you know these values are only for mild steel, and if you are using HYSD steel, for HYSD steel, these values are multiplied, above values are multiplied by 0.8. By 0.8. Understood, everyone? These values are multiplied by 0.8. So you can see you can span upon depth is given as 300 mm and the ratio is given as 35. So you can see the span length will be equal to, the span is in mm. So 35 into 300. 35 into 300. So your answer will be multiplied. You will get the answer as 10500 mm. 10500 mm is the answer. Yes or no? Option D is the correct answer. Yes, 10500 mm. 10500 mm. Yes or no? Clear, everyone? Okay, moving ahead with the next question. Is understood, everyone? Just a moment. I remind student on Telegram that the session has been started. Moving ahead with the next question. This is the second question for today's class. Answer this question. In case of two-way slab, the limiting deflection of the slab is, now this is a very good question. Now whenever you check for deflection, okay, which span will you take? In case of two-way slab, the limiting deflection of the slab is primarily a function of long span, primarily a function of short span, independent of long and short span, dependent on both long and short span. This is a very good question. Answer this question. Vaibhav, Vishnu, the correct answer is no. No, the correct answer is no. Vishnu Pandey, the correct answer is not D. The correct answer is option B. B for Bombay. Whenever you check for the limit deflection, okay, whenever you are checking for the deflection in two-way slab, always shorter span is used. Understood, everyone? Always shorter span is used. So limiting deflection of the slab is the function of shorter span. Option B is the correct answer. Understood? Please please put a star mark on this. Whenever in two-way slab you are checking for deflection criteria, always you will use the shorter span. Understood, everyone? Option B is the correct answer. Now moving ahead. Answer this question. For design purposes, the width of one-way slab is always taken as. Again a very good question. Now for always the design criteria, let us suppose I have marked the this is a slab. For design purpose, you always take for design, let us suppose this is the slab. For design, you will always take it the width as, you always consider this portion of the slab, and this portion of the slab, the width of this is nothing but now this width is 1 mm, 100 mm, 200 mm, this width is 1 meter. Yes, very good. 1 meter means 1000 mm. Option C is the correct answer. Understood, everyone? Always we take the width as the 1000 mm. Option C is the correct answer. Moving ahead with the next question. So in this chapter, I'll take 40 questions. Okay, I'll take 40 questions, and in the evening for column chapter, we will take roughly around 40 questions of column also. Answer this question, everyone. What is the correct answer? Minimum reinforcement required in either direction in slab reinforced with high strength deformed bar. Now this is nothing but percentage of the gross cross section area, 0.11. Very good. The correct answer is whenever you are using high strength deformed bars. For high strength deformed bars, the minimum reinforcement in slab, okay, minimum reinforcement in slab is considered to be 0.12% of the gross cross section area. Yes or no? Now I'll finish. For 2 days I have to go somewhere at one of my relative place. That is why there was a break. Otherwise I won't discontinue it. Okay, I will discontinue only when we will be able to solve all the questions of this series. Understood? In evening I will take column as well as footing. So 2 chapters are also left again, the column as well as footing. This we will cover. Understood, everyone? Also in this playlist you will see that I have taken question for SSC JEE previous year also, but that is in Hindi. Okay, that is in Hindi. I have taken almost 20 years question of SSC JEE previous year, so you can refer the playlist. Okay, so you can see very carefully, high strength deformed bars, minimum reinforcement is 0.12% of the gross cross section area, and whenever you are using the mild steel, how much is the minimum reinforcement you will provide? 0.15% of the gross cross section area. Clear, everyone? Now moving ahead with the next question. This is the question. Answer it. This is a very good question. Please put a star mark on this. Most of the students will give the wrong answer for this. Please put a star mark. हाँ, करवा देंगे भाई. बिल्कुल करवा देंगे, पहले ये फिनिश हो जाए फिर करवा देंगे, ठीक है। आरसीसी स्लैब, what is the correct answer? Very good, Vishnu, Vaibhav, very good. Vaibhav have given the correct answer. I want answer from other student also. Now look, a RCC slab under mild exposure condition having main longitudinal tension reinforced. Now let us suppose the main bar has a diameter of 12 mm. The main bar has diameter of 12 mm. Okay, the RCC slab under mild exposure condition having main longitudinal reinforcement of diameter 12 mm. Then minimum allowable nominal cover to satisfy the durability requirement. In order for the durability requirement for this 12 mm bar, the minimum cover is reduced by, in the slab minimum cover is reduced by 5 mm, reduced by 5 mm. Okay, 5 mm. So we know that what is the nominal cover, minimum nominal cover for slab, nominal cover for slab is nothing but 20 mm, is 20 mm. So for this durability criteria you have a chance of reducing it by 5 mm. So what is the minimum nominal cover? 20 minus 5, that is equals to 15 mm. So your correct answer is option B is the correct answer. 15 mm is the correct answer. Understood everyone? Now moving ahead with the next question. Answer it everyone. Answer this question. In case of non-cellular, non-ribbed flat slab, what is the correct answer? This is a very good question. In case of non-cellular means non-ribbed. I'll show you the diagram. Ribbed and non-ribbed flat slab. This is a non-ribbed flat slab. The spacing of the steel reinforcing bar shall not exceed a meter in m times the thickness of the slab, where m is. Now you can see, if I show you, just a moment. Now you can imagine this, that the slab, this is a flat slab, this is not ribbed. Understood? So over the slab, their slab is placed over the column. So this is known as non-ribbed flat slab. Okay, or in case of non-cellular, non-ribbed flat slab, the spacing of the steel reinforcement bars shall not exceed 2 times the thickness of the slab. So remember this codal provision, the reinforcement bar should not, the spacing should not exceed 2 times the thickness of the bar. So here I'll show you the thickness. This is the thickness of the, slab. Understood everyone? So thickness of the slab I have shown you here. So maximum spacing is the 2 times the thickness of the slab. Please put a star mark on this. Please put a star mark. Okay. Moving ahead. Answer this question. Answer this question. The maximum theoretical diameter in mm of steel reinforcement slab 180 mm thick is the maximum theoretical diameter. This put a star mark on this. If let us suppose the thickness of the bar is, the thickness of the slab is 180 mm. So what is the maximum theoretical diameter? Theoretical wise, what is the maximum diameter of steel bar you will use here? What is the correct answer? Theoretically, what is the maximum size of steel bar that you will use here? What is the correct answer? Yes, very good Vishnu. So what is the maximum dia of bar? Maximum diameter of bar. So what is the maximum diameter of bar? 1/8 times of the thickness of the slab. 1 by 8 times of the thickness of slab. Yes or no? Thickness of slab. Now look very carefully. 1 by 8 times of the thickness of the slab is nothing but 180 mm. So what is the correct answer? 180 means 90 by 4. 90 by 4 means 45 by 2. 45 by 2 means 22.5 mm. So the maximum diameter of bar that you'll use here is 22.5 mm. So theoretical wise, you'll use 22 mm diameter bar for this slab. Yes or no? The maximum diameter of bar is 22.5 mm. So this is again a very good question. Answer this question, everyone. Again, this is a very good question. One-way slab. What is the correct answer? In one-way slab are those in which most of the load is carried on which span? The correct answer is longest, shorter, middle or quarter. What is the correct answer? Now in one-way slab you can see they are supported on one side. Okay, so you can see the main bars are provided on the shorter span and distribution bars are provided on the longer span. Please remember this, that the maximum load is carried on which span? Shorter span. Understood everyone? On shorter span. Okay, so the main reinforcements are provided on shorter span. Okay, and distribution bar are provided on longer span, Understood everyone? So you can see main reinforcement are provided on shorter span. Option B is the correct answer. Clear everyone? Clear? We'll move ahead with the next question. The distance between main bar in a simply supported should not exceed. The distance between main bars in a simply supported slab should not exceed by 3 times of effective depth, 4 times, 5 times and 6 times. This is also a very good question. What is the correct answer for 9th? In this question there is some amendment. Now in this question there is a recent amendment, not recent, but there is an amendment on this. What is the correct answer? The distance between main bars in a simply supported slab should not exceed by. Now for main bars you can see, for main bars the maximum distance should not exceed 3 times of the effective depth. Okay, so maximum distance is, okay, maximum distance should not exceed by 3 times of the effective depth. Okay, or 300 mm or 300 mm, whichever is less. But whenever you are providing, yes, answer is option A. Whenever you are providing the reinforcement for temperature and shrinkage, whenever the reinforcement is provided for temperature and shrinkage, whenever the reinforcement is provided for temperature and shrinkage, the maximum spacing is in earlier it was 3 times of the effective depth or 450 mm. 5 times of effective depth, 5 times of effective depth or 450 mm, but now it is changed to 300 mm. 300 mm, whichever is less. So this is the amendment. Understood everyone? Here it is for main bar, so answer is 3 times of the effective depth. Option A is the correct answer. Good afternoon, Vignesh. Understood? This is the correct answer. Option A is the correct answer. I hope it is clear. So this is the amendment. Clear everyone? So in bar, in slab, okay, whenever for main bar the maximum spacing is 3 times of the effective depth or 300 mm, whichever is less, but for temperature and shrinkage, if you have provided the reinforcement, it should not be more than 5 times of the effective depth or 450 mm. This was the previous code, but now this is the amendment. It is reduced to 300 mm. Yes or no? The correct answer is option A. Option A is the correct answer. I hope it is clear. Now, very good. Now, solve this question. Thickened part of flat slab over the supporting column is called. Now, this is the question for flat slab. Understood? Now, you can see if this is the slab, this is the slab. Okay. This is the column. Now, this is the column. This is flat slab. Okay. Now, this is drop panel. This is column capital. This portion, this tapered portion is known as column capital. This is known as column capital. And you are asked in the question that what is this flat part, thickened part of flat slab? This is known as this is not apital, this is column capital. This is column capital. Option B is column capital, and this is known as drop panel. This portion is known as drop panel. Drop panel. Understood? So this is the flat slab. Clear everyone? So you can see very carefully, thickened part of the flat slab or the supporting column. This is the thickened part of the, that is known as, yes, the correct answer is, now here this thickened part, you are asked with this part. You can see this part you have asked. This part is known as, drop panel. Option A is the correct answer. Okay, understood everyone? This is known as column capital. This tapered portion is known as column capital, but this portion is known as drop panel. Understood, Vignesh? Option A is the correct answer. Now, if there are one more type of flat slab, look at this. Look at this part. This is flat slab with column capital. So this is the diagram. This is known as, this is column, and this is known as column capital. This is flat slab with column capital and drop panel. This is flat slab with column capital. Understood? So the correct answer is option A. Drop panel is the correct answer. Clear everyone? Moving ahead with the next question. Answer this everyone. For slab spanning in two directions, the ratio of span to depth for simply supported slab should not exceed. For slab spanning in two directions, the ratio of span to depth for simply supported slab should, this question we have just covered. For two-way slab, okay, for two-way slab, okay, spanning in two direction, okay, it is spanning in two direction, the ratio of span by effective depth, the ratio of span by effective depth ratio for simply supported slab, okay, for simply supported slab it is 35 and for continuous slab it is 40. For simply supported slab it is 35 and for continuous slab it is 40. So here the correct answer is option C is the correct answer. Very good. Yes, for these are for mild steel. But if you are using the high strength HYSD bars, high steel deformed bar, above values are multiplied by 0.8. Above values are multiplied by 0.8. Yes or no? Moving ahead. Answer this question. Again a very good question. Answer everyone. In simply supported slab, okay, in simply supported slab, alternate bars are curtailed at very good, very good. Alternate bars are curtailed at span by 7. This is the good, very good. Please put a star mark. So if there are some bars, one bar is this, one bar is this, so alternate bars, let's suppose this one and this one, so alternate bars are curtailed at span by 7. Option C is the correct answer. Please put a star mark on this. So span by 7, so alternate bars are curtailed at span by 7. Understood? Now moving ahead, this again, this is the very good question. Answer this. The slab is designed as one way if the ratio of long span to short span is this is a very simple question. This slab is designed, so for one way slab, the ratio of long span to the short span, if the ratio, for example Ly by Lx, okay, if the ratio is nothing but greater than equal to 2, the slab is called as one way slab. If it is less than 2, it is known as two way slab. One way slab, just a moment guys. Okay guys, so what is the correct answer for this? What is the correct answer? If the slab is designated as, designed as one way, the ratio of long span should be greater than equal to 2. So correct answer is option B, yes or no? So this is the correct answer. Moving ahead, next question. In case of flat slab, the minimum thickness of slab shall be, very good question. For flat slab, okay, what is the correct answer for flats in case of flat slab? For flat slab, the minimum thickness should be, the least thickness should be 125 mm, okay. So the minimum thickness of flat slab should be 125 mm. Option C is the correct answer. Understood everyone? Option C is the correct answer. Minimum thickness of flat slab. So in case of flat slab, the minimum thickness of flat slab is, minimum thickness of flat slab should not be less than 125 mm. So the correct answer is option C. Understood? Moving ahead. Answer this question everyone. Enlarged head of supporting column of an reinforced cement flat slab is called. This question just now I have discussed with you. Just now I have discussed. What will be the correct answer? column head, drop panel, none of these, capital. Now see, this is the flat slab. I'll show you 3 diagram. Okay, this is flat slab, this is flat slab, understood? This is flat slab with column capital, this is flat slab with column capital. Look, this is flat slab with column capital, understood everyone? And this is flat slab with drop panel, this is flat slab, this is flat slab with column capital and with drop panel. So these are the 3 type of flat slab, understood everyone? Understood? This is flat slab, this you can see, this is known as flat slab, yes or no? This is flat slab with column capital, flat slab with column capital. This is flat slab with column capital and drop panel, flat slab with column capital and drop panel. Yes or no? So the correct answer is column capital. Option A is the correct answer. Yes or no? Moving ahead. Answer this. This is also a very good question. Please don't use, please only use virtual calculator while solving any type of question. Solve virtual calculator everyone. You can see, for it is a one-way simply supported slab. You can see dimension is 9 meter by 4 meter. So you can see Ly is nothing but 9 meter and Lx is nothing but 4 meter. So the ratio of the longer span to the shorter span, the ratio of longer span by shorter span is greater than 2. So it is a one-way slab. It is a one-way slab. Understood everyone? It is a one-way slab. Ultimate. So working load is nothing but, working load in question is given as, working load is given in the question as 9 kilonewton per meter. The design moment is design moment. In design moment we always take which span? The shorter span. So WL square by 8, WL square by 8. So 9 into length is nothing but 4 meter, 4 square divided by 8. So your correct answer will be 16. So 18 kilonewton meter is the correct answer. 18 kilonewton meter is the correct answer. Option B is the correct. Understood? Yes or no? Okay. Now moving ahead. Answer this question. Answer 17th question. Drops are provided in flat slab. So why the drops are provided? Now the flat slab resist over the flat slab resist. So drop is, now this drop is provided to resist the shear. Please remember, this is column head. Okay, column head is provided because of the compression failure of the column. Okay, because from the slab, from larger area the load will transfer to the column. This is the column head, column capital. Okay, so this drop is provided to resist the shear, so this is the drop panel. Okay, so drop panel. So this drop panel is given in order to resist the shear. Option A is the correct answer. Clear everyone? Moving ahead. Answer this question. In two-way slab, the main reinforcement is provided along. Again a very simple question. Answer this. No, this is a two-way slab. It is not one-way slab. Now you can see very carefully. This is nothing but a one-way slab. But if the bending is taken place in both the direction, if I support it like this and support it like this, so deflection is like this also and deflection is like this also. Understood? That is known as two-way slab. So in two-way slab, please note that in two-way slab, the main reinforcements are provided in both the direction, in both short and long span, because the deflection carried out in both the direction. Yes or no? In both these. But if it is a case of one-way slab, the main reinforcement are provided in the main reinforcement is provided in which span? Main reinforcement is provided in shorter span. Yes or no? Understood everyone? Clear? So here the correct answer is option C. Now moving ahead. Now this is a very good question. Most probably you will get the question. This is in your RRB JE examination. Very good question. Very important question. Answer this. The main reinforcement in a RC slab consists of 10 mm bar at a spacing of, so 10 mm reinforcement bars are provided at a spacing of 100 mm spacing. Understood everyone? 100 mm spacing. Now again it is given as center to center. If it is desired to replace the 10 mm bar by 12 mm, now you have replaced the 10 mm bar by 12 mm. So comment about the spacing. Spacing will be less than 100 or more than 100? Now if you have provided the longer span, now spacing will be more than 100. So the first thing comes in your mind is spacing is more than 100 mm. Yes or no? More than. So all the options are more than 100 mm. So option A will not be the correct answer. Either you will get B, C, D. Understood? One option you have eliminated. Now what is the formula? Spacing formula in slab? Spacing in slab is equal to nothing but pi by 4 into phi square 1000 upon AST. Now you can see very carefully, spacing is directly proportional to the diameter square if all the things are constant. If width of the slab is 1000 mm and the area of steel is same. Now for example, here the spacing for the 10 mm bar, 10 square is upon 12 square is equals to spacing is 100. Now here the spacing is x. So your answer will be nothing but 144. Okay, 144. X is nothing but 144 mm. So your answer will be option C is the correct answer. Clear everyone? So this is the formula. Please remember this formula for spacing in the slab. Clear? Clear everyone? Now moving ahead. Now please put a star mark on this. A steel beam supporting load from the floor slab as well as from the wall is termed as. Now from the floor slab you have provided the beam. The beam is known as lintel beam, is provided in the above the door or window, such that above the door or window whatsoever be the brick masonry, the load will comes to the lintel beam. Okay, the correct answer is spandrel, stringer or header beam. No, I'll show you the diagram also. First of all, I'll show you the stringer beam. You can see. Just a moment, I'll show you the stringer beam. Stringer beam. See. Stringer beam as well as so in the question 3 beams are given. I'll show you 2, stringer and spandrel beam. Stringer beam as well as spandrel. Just a moment. Is this image clear? Is this image clear, everyone? Now you can see the correct answer is spandrel beam. Very good, everyone. So this is the for below. Now you can see stringer beam is below the this beam is stringer beam. You can see this beam is stringer beam. Okay, this is provided below the it is not visible. Just a moment. Now it is clear. Now it is clear. You can see very carefully this beam below the staircase. This beam is nothing but this beam is stringer beam. Yes or no? You can see. Yes or no? Now I'll show you the spandrel beam. This is spandrel beam. This beam. This beam is spandrel. This one is the spandrel beam. So it will carry the load from the floor also, from the wall also. Yes or no? Yes, bottom part of the stair is stringer beam. Understood? So you can refer here the question. Refer the question. A steel beam supporting the load from the floor slab as well as from the wall. So below the wall as well as from the floor slab, that is spandrel beam. Option C is the correct answer. Understood? Option C is the correct answer. Now moving ahead, answer this question. The main reinforcement, again this is a very good question. Very good question. I have already told you the formula for spacing of the beam. So what will be the correct answer? Those students are from Maharashtra. Okay, Mahatransco vacancies, the link for Mahatransco vacancies are open now. Okay, that is a very good opportunity to become the assistant engineer in your examination. Very good vacancies. Yes or no? Those students are from Maharashtra, they can apply for Maharashtra, okay, Mahatransco examination. The links are open now to fill the form. You know, there are very good opportunity for Maharashtra student as the vacancies for New Mumbai Municipal Corporation as well as for Mahatransco as well as for MPSC. Okay. The main reinforced RCC slab consists of 10 mm bar. So 10 mm bars are there, and what is the spacing? 100 mm spacing are there. 100 mm spacing. If they desire to replace 10 mm bar by 12 mm, so what will be the spacing? Spacing will be 144 mm, or 144 mm means 14.4 centimeter. 14.4 centimeter. That is option C is the correct answer. Just now I have for 144 14.4 will be the answer. How it will be 14.4? Vignesh, I just told you the example that spacing is directly proportional to the diameter of the bar. Yes or no? Square of the diameter of the bar. So if the spacing is 100 mm, 100 divided by spacing is x is equals to 10 square upon 12 square. Yes or no? So you can see very carefully, 100 x is equal to x value is equals to 100 into 144 divided by 100. So your answer will be 144 mm. So it will be 14.4 centimeter. Option C is the, that is why option B is given, in order to make you confused. Understood? Now moving ahead. So you must have seen that from this is the 6th lecture. I have framed such a question that you won't get these questions in your previous year. Understood, everyone? So this is how we will try to solve one more subject after this. Option C is the correct answer. Now moving ahead. In an interior span of flat slab, the negative design moment is taken as times the total design moment. Again, this is a very good question. Now for interior span, now you can see for interior span, negative design moment is as well as positive design moment. So what is the value for, no, Sachin, 0.5 is not the correct answer, brother. So the correct answer is for negative bending moment, it is 0.65 times of the, so in interior, okay, in interior, we will take the design moment as 0.65 times of the point for the total design moment. Total design moment, and for positive bending moment, it is 0.35 times of the total design moment. Total design moment. So what is the correct answer? 0.65. Negative, no. So negative design moment is 0.65 times of the total design moment. Option C is the correct answer. Moving ahead. Now answer this question. Answer this question. In an under reinforced one-way slab with effective depth of 100 mm, the main answer this question. Please use virtual calculator in order to solve this question. Now you can see in an under reinforced one-way slab. So in question it is given as under reinforced one-way slab. Now this is the under reinforced. So in under reinforced one-way slab, with effective depth of 100 mm, the main steel is provided as 10 mm bars at 200 mm center to center. Okay. The moment of resistance of the slab for M20 grade of concrete Fe415 steel is. Now you are asked with moment of resistance. Effective width is taken to be 1000 mm, 1 meter or 1000 mm. So this is the, and depth is taken at 100 mm. Depth is taken as 100 mm. Yes or no? Okay. Now the spacing is nothing but 200 mm. The bars are, so what is the formula of spacing? Spacing is nothing but 1000. What is the width? 1000 mm into pi by 4. What is the diameter? Diameter is 10 mm upon what is the AST, area of steel. So from here area of steel can be computed. So spacing AST will be equal to area of steel can be computed 1000 into pi by 4, 1000 into pi by 4 into 10 square divided by what is the spacing? 200. So from here AST is computed. Whenever you get the AST, okay, you have calculated the AST. Moment of resistance can be calculated as, now depth, in order to get the depth of neutral axis 0.36 FCK B into XU is equals to 0.87 FY into AST. Okay, so from here XU can be calculated. XU can be calculated as 0.87 FI. FI is nothing but 415. What is the AST? From here you will get the AST. Okay, from here you will get the AST as well as upon 0.36. What is the grade of the concrete? Grade of concrete is 20 and width is nothing but, effective width is nothing but 1000 mm. So from here you will get XU. From here you will get XU. Yes or no? AST is 392.7. So this is 392.7 mm square. 392.7 mm square. So from here you will get the XU value as 19.7 mm. 19.7 mm. So what is the moment of resistance? Moment of resistance can be calculated as 0.87 Fy into AST. AST D minus 0.42 XU. D minus 0.42 XU. All the values are given. 0.87 Fy value is 415. AST value is nothing but 392.7. 392.7. D is nothing but effective depth is given as 100. 100 minus 0.42 into XU value is 19.7. So in order to convert this in kilonewton meter, multiplied by 10 power minus 6. So it will take long time to cover this question. Your answer will be 13 kilonewton per meter. 13 Newton kilonewton meter. So in slab, it is the most common question. This is not the question for your RRB JE examination. Rather, you will get such type of question in your GATE examination. Just look at the answer. Understood? Yes or no? This is the answer. I hope it is clear. Yes or no, everyone? Now moving ahead. Moving ahead. Solve this question. Answer this. In two-way slab, the torsional reinforcement is provided at. Now this is a good question. Please note down, whenever the slab is continuous, no need to provide the torsional reinforcement. For continuous slab, no need to provide the torsional reinforcement. Answer this. So whenever there is slab is two-way, okay, torsional reinforcement is provided mid depth only, top face only, bottom face only, and top and bottom. Very good, very good, Vignesh. So torsional reinforcements are provided at top face also, at the bottom face also. Understood? So the correct answer is option D. But please mind it, whenever the slab is continuous, no need to provide the, so this is the codal provision that whenever for continuous slab, so whenever for the edge is continuous, for continuous edge, okay, no need for torsional reinforcement. Understood? Moving ahead. Answer this. The answer for 25th question. Now in monolithic slab beam, so you can see this diagram. This is monolithic. Okay, this is monolithic. I mean, beam is casted with the slab. Yes or no? Beam is casted with the slab. So this is monolithic. So whenever you have cast the monolithic slab, okay, main reinforcements are parallel to the beam. And how about the transverse reinforcement? Transverse reinforcement are, you are asked with the transverse reinforcement. Now the correct answer is not B, option C is the correct answer. Now 60% of main reinforcement at midspan. So at the midspan, so this is the main reinforcement. At the midspan, you can see at the midspan, these are nothing but the transverse reinforcement. Transverse reinforcements are 60% of the main reinforcement. At midspan, at least at the midspan, you will get 60% of the reinforcement of the main reinforcement. Understood, everyone? Option C is the correct answer. Moving ahead. Now in limit state method, the failure criteria for reinforced concrete beam and column is based on, now beam and column is based on maximum principal stress, maximum principal strain, maximum shear stress and normal stress theory. What is the correct answer? So whenever, so in limit state always you remember that when a concrete or steel will be treated as failure, so this is the basic criteria. I mean, this is the basic design criteria in limit state method. Whenever you treat the concrete or steel to be failure, when the strain in the concrete reaches to 0.0035. Do you understood? Or in axial compression, what is the maximum strain? And what it is shrinkage strain? 0.0003. Yes or no? So this is a strain controlled approach. So limit state method is the failure criteria for reinforced concrete beam and column is based on which criteria? Principal strain theory, maximum principal strain theory. Maximum principal strain theory. Understood everyone? Clear? Now moving ahead, next question. Answer this question. According to IS 456, two-way slab with corner held down are assumed to be divided in each direction into middle strip and edge strip such that the width of the middle strip is. This is also very good question for two-way slab. Whenever we design the two-way slab, okay, if let us suppose this is the two-way slab, okay, and this span is nothing but LX or LY. You can assume it any of the possible. Let us suppose this is LY. So we divide this into three strip. Okay, we divide this into three strip. Okay, the middle strip and the outer strip. Okay, so what is the, you are asked with this. You are asked with this. I'll give you the hint. This is nothing but L upon 8. This is also L upon 8. So L upon 8 of Y, LY by 8. This is also LY by 8. So if you add this, you will get LY by 4. So remaining will be equal to 3 by 4 of LY. 3 by 4 L4, yes, 3 by 4 of LY. So this is nothing but 3 by 4 of LY. Edge strip, middle strip. So this is nothing, this is known as middle strip. This is nothing but edge strip. This is also edge strip. So your correct answer will be 3/4 of the width of the slab. 3/4 of the width of the slab. Option C is the correct answer. I hope it is clear. Yes or no, everyone? Clear? Please put a star mark on this. This is also a very good question. I hope it is clear now. Clear everyone? Now moving ahead. Answer this question. Now, if W is the load per unit area on the circular slab, please remember this is a circular slab. Okay, this is the circular slab of radius R. Now, you are given with this radius R. This radius is R. Okay, the maximum radial moment at the center of simply supported slab. This slab is simply supported. Now, what is the bending moment in the circular slab? What is the circumferential moment? So, here in the circular slab, we will consider this moment as circumferential moment. This is given as circumferential moment in circular slab is given as, okay, radial or circumferential moment is 3W R square minus R 3W capital R square at any radius you can calculate upon 16. Okay, 16. Yes or no? And you are asked with the center. At center the radius is, small radius is 0. So you will get the value as 3W R square upon 16. So at center the value is 3W R square by 16 is option C. Please remember this formula. Only you remember the formula, not the design part. Okay, design part is not in your syllabus, but you remember the formula. So how do you calculate the circumferential moment at any radius? If let us suppose you are asked to find the circumferential moment at this portion. Okay, this portion is, let us suppose the radius is small r. So we'll get the value as 3W R square minus small r square upon 16. Here the answer is option C. Clear everyone? I hope it is clear. Yes or no? Now moving ahead, still we are left with 10 more questions. We will complete the question now. Answer this question. As per IS 456-2000, bending moment M for two-way RCC slab can be calculated using the equation bending moment My. Now you are asked with My, bending moment My for longer span for two-way RCC slab can be calculated using the equation. Now please remember, in two-way slab, okay, the longer span denotation is Ly and the shorter span is Lx. What is the equation? What is the equation, everyone? For longer span, this is longer span. This is shorter span. Understood? So whenever, now please remember this very carefully. Now look, here the correct answer is no. Yes, very good. Now whenever you are asked to find My, you can see very carefully My. Whenever you are asked to find the moment about the y-axis, these are the moment coefficient. These are the moment coefficient. Moment coefficient about the y-axis is taken. Load per unit area as well as length about the x-axis is taken. Now you can see that this is the bending moment. This is a two-way slab. Okay, we are asked to find the moment about this axis. You are asked to find the moment about this axis. Whenever you are asked to find the moment about this axis, you can see this length get deflected. This length get deflected. Yes or no? So which length will you take? The length which is perpendicular to the reference axis. This is the axis. What is the length? This is the length that you have to take. Clear, everyone? I hope it is clear now. So the correct answer is option B. B for Bombay is the correct answer. Clear? Moving ahead. What are anchor bolts? What are anchor bolts? Anchor bolt, you must have studied this in steel also. Anchor bolts to resist overturning moment are used in the slab base. To resist overturning moment are used in the slab base when column carries only moment, when column carries axial load, when column carries axial load and moment, the column carries no load. You can see. Now, anchor bolts are provided, you can see, whenever the column is carrying the eccentric load. The column is carrying the eccentric load. Okay. Now, because of this eccentricity, what will happen? You will shift this load to the center and a bending moment of P into E. Because of this P load, yes, because of this P load, this will give you axial compression, and because of this moment P into E, okay, because of this will give you the moment, yes or no? This will give you the moment. So whenever a column carries the axial load as well as moment, the anchor bolts are provided in slab, okay, in slab base. Option C is the correct answer. Clear? The correct answer is option C. Moving ahead, next question. Please answer this. The torsional reinforcement for corners held down in the slab provided at. Now, please answer this. Now I have already given you the hint that torsional reinforcements are not provided for continuous edges. Yes or no? So whenever the edges of the slab are continuous, okay, let us suppose I'll form you the slab. Look at this slab. Look at this slab. Let us suppose this is the slab. All the corners are continuous. You can see this corner also continues ahead. This also continues. This also continues. This also continues. All the corners are continuous. So all this slab has all the corners continuous. So for this slab, no need to provide for torsional reinforcement. So it means that for discontinuous edges, for example, for this edge, you can see for this edge, this is discontinuous. For discontinuous edge, you need to provide the torsional reinforcement. Hence, option B is the correct answer. Option B is the correct answer. So you can see for this slab, all the four corners have continuous edge. For this slab, you can see this edge is discontinuous, this edge is discontinuous, this edge is discontinuous, but this edge is continuous. Yes or no? Yes or no, guys? Okay. Moving ahead with the next question. Answer this. This you need to remember that I'll give you the hint also. What is the correct answer? Please remember it. This is WL square by 12. For continuous slab, okay, the bending moment near the middle of the end span is WL square by 12. The correct answer is option C. Please answer this. Please put a star mark on this and solve the question. This concept just I have given you in this lecture only. For a continuous slab of 3 meter into 5 meter size, the minimum overall depth of slab for satisfy vertical deflection limit with mild steel. Please remember mild steel reinforcement. So the slab is 3 meter by 4 meter. The shorter span is 3 meter. Okay. Shorter span is 3 meter. The minimum overall depth. Okay. The slab by depth ratio for continuous slab is, please solve it by slab by depth ratio. What is the correct answer? Now for continuous slab, we have given you the question answer as span by effective depth ratio. This value for mild steel it is given as 40 for a continuous slab, and in the question it is given as continuous slab. So what is the span by depth? So you are asked with the depth. So which span will you take, the shorter one or the longer one? The shorter one or the longer one? Please answer it. Always remember, for deflection criteria, shorter span is taken. So what is the shorter span? 3 meter or 5 meter? 3 meter means 3000 mm upon depth is equal to 40. So you'll get the answer as the effective depth has 3000 divided by 40. So this is nothing but 300 by 4 is nothing but 0.75, 75 mm. 75 mm, option D is the correct answer. Understood everyone? 75 mm, D is the correct answer. Okay, moving ahead. Last 5 question, guys. Last 5 question, then this chapter will be finished. The effective width of a column strip of a flat slab is taken as, the effective width of column strip of a flat slab is taken as, no, the correct, no, not 1/4. It is not 1/4. It is half the width of the panel. It is half the width of the panel. Now moving ahead. Answer this. Design of a two-way slab simply supported on edges and having no provision to prevent the corner from lifting. Okay, no provision, so the corners are not held down. Please remember, you need to design the two-way slab. You need to design the two-way slab simply supported on the edges and no provision to prevent the corners. So there is no boundary wall over the slab. It means corners are not held down. No provision to prevent the corner from lifting. Okay, so there is no provision. Corners are not held down. Okay, corners are not held down. So by which method you will design? Corners are not held in. The correct answer, no, please remember very carefully, in two-way slab, okay, when corners are not held down, okay, so this is derived by Rankine-Grashof formula, and whenever you need to design two-way slab, corners are held down. This is designed by Marcus formula. Understood everyone? Remember? Okay. Moving ahead. Answer this question. So last three questions are there, 36, 37, 38. Three questions are there. Answer this. For a circular slab carrying a uniformly distributed load, the ratio of maximum negative to maximum positive radial moment. Now please remember, in circular slab, so circular slab is not so important for your examination. Why? Because in SSC JE also very less questions are asked from circular slab. Okay, so this is very least important for your RRB JE also. What is, yes, correct answer is 2. So in circular slab, what is the formula for maximum positive bending moment? Maximum positive bending moment. And what is positive radial bending moment? And maximum negative bending moment. So what is the positive bending moment and negative bending moment? What is the value? Negative bending moment is 2W r square by 16. 2W small r square by 16. So what about the maximum negative bending moment? This is, negative bending moment is, so positive is W r square by 16. So it is 2W r square by 16. So we'll take the ratio of negative to positive. Negative to positive is 2. Negative to positive is 2. Yes or no? Moving ahead. Next question. Distribution reinforcement in simply supported slab is provided to distribute. Now, why we provide the distribution bars? So you can see in one-way slab, main reinforcements are provided in shorter span, but longer for distribution bars are provided in the longer span. Okay, so why the distribution bars are provided? In order to distribute the load, shrinkage stress, temperature stress, all of the above. Very, very good. Whenever you need to consider shrinkage, temperature, also they distribute the load. Hence all the options are correct. Option D is the correct answer. All of the options are correct. Option D is the correct answer. Understood everyone? moving ahead. Yes. Answer this question. In two-way slab, corner steel is provided to counter. Now, why the corner steel is provided? Why the corner steel is provided? Now you can see at the corner the stresses are such high because of the at the corner torsion exists. In order to resist the torsion, as well as because of the torsion there is chances of uplifting of the corner. Hence, to restrain the corners from uplifting, the corner steels are provided. In two-way slab, corner steel is provided to counter uplift of the corner, and they also resist the torsion. Yes. So here the option C is correct answer. Now the last question is this. Corner steel is provided in slab to resist the bending moment, to make the slab sufficiently rigid to resist torsional moment, to prevent displacement of the corner. So they resist the torsional moment. Understood everyone? They resist the torsional moment. Option C is the correct answer. Clear everyone? So this completes your slab chapter. We have covered almost 30-40 questions for slab. Okay, slab we have covered. Now we are left with column and footing. We are left with corner and footing. Most probably today there is class. Today in evening also I will take the session so that you can revise the whole RCC in one go. So in today's session, most probably at 7 p.m. or at 8 p.m. Most probably at 7 p.m. in the evening, I will take the session for column. So today only we will cover the question for column, so that your 99% of the RCC questions are covered today only. At what time? 7 p.m. So today in the evening at 7 p.m. okay, I will take one more session for column. So today we will cover the most important questions for RCC. Clear everyone? So we will discuss in the evening that after this subject, which subject do you want. But in the evening session, I will cover the one more topic, that is column. Understood everyone? So thank you so much guys, and please share it maximum to among your friends so that they also get quality questions from these sessions. Understood everyone? Okay. So in evening I'll cover the column chapter. We'll meet you in the 7 p.m. in the evening. Yes or no guys? Thank you so much everyone. Please share it and please like the session. Okay. And if you have feedback about the session, please do mention in comment section so that it will be beneficial for me to rectify my mistakes as well as to grow better. Okay, thank you so much guys. We'll meet you in the evening. Thank you so much everyone. Bye bye.